This is going to be a video tutorial on how to use the drawing tools in the Chapter 8 homework to answer problems like problem 8.4 here. I've had a request from a student to do a video tutorial on this, so I think probably a lot of people will find this helpful. So I'll go ahead and post this on the YouTube channel, and hopefully everybody that has a question about this will be able to use this for help on how to do this problem. So in problem 8.4, there's three parts. Part B is just a drag and drop. I don't really think I need to explain that one. But Part A and Part C ask you to use the drawing tools provided to draw the molecule benzene, C6H6. Now, for obvious reasons, I'm not going to do that as an example, because I don't want to answer this homework question for you. But what I will do is I'll use the drawing tools to draw a different Lewis dot structure. So for an example, we can use formaldehyde, CH2O, which was an example from Chapter 7 on how to draw Lewis dot structures. And the final structure you can see here is a carbon, double bonded to an oxygen, and single bonded to two different hydrogens. And the oxygen has two lone pairs of electrons on it after you go through all the steps and complete the octets. So what we'll do is we'll go back to this tool for Part A. I'll show you how to use this to draw, in this example, formaldehyde. Of course, when you're answering this question, again, you'll want to draw benzene, C6H6, not CH2O. But what we can do is we can come over to this toolbar here. You can see there's some common elements, carbon, hydrogen, oxygen, nitrogen, and so on, that we can use to draw a Lewis dot structure. And there's a carbon in the middle of our formaldehyde molecule in CH2O. So we'll go ahead and drop a carbon in by clicking on the chemical symbol here for carbon and just putting that down. Hopefully you can see that there's a carbon atom represented by a letter C here. Next, what we need to do is attach two hydrogen atoms and one oxygen atom to this, and the oxygen atom should be attached via double bond. Let's go ahead and attach the oxygen first. So the way we can do this is we can click on the chemical symbol for oxygen, and we want to use the appropriate bond. So up here in the upper left we have the option of single bond. We'll be using that for the hydrogens, and in the case of oxygen we need a double bond. So what we'll do is we'll hover over the carbon we previously put down, and we'll drag our mouse out until we get an oxygen, and as you can see we now have a carbon-oxygen double bond drawn in. Now to put the hydrogens on, we can choose the chemical symbol for hydrogen, and those are single bonds, so we're going to drag from carbon to wherever we want our hydrogen to go. So for instance here and here. So we've attached our two hydrogens. Then of course we need to include the two lone pairs on oxygen, so we can choose a pair of electrons here, and we can just click on the atom that we want to add that to. So for oxygen we can do that once, twice, and you can see that there's two lone pairs on this oxygen. So that's how you use the drawing tool in Part A. Let's go ahead and move down to Part C here, where they ask us to draw a three-dimensional representation of the molecule. Now, in the case of formaldehyde, if you follow the VSEPR rules, we can see the carbon in the middle here is attached to three atoms, two hydrogens, one oxygen, and it doesn't have any lone pairs. So this is going to be a trigonal planar molecule, and we want to reflect that when we draw the structure in this drawing tool for Part C. So this works kind of similar to how we might do this in the previous case in Part A. So again, our molecule is going to center around carbon, so you can see if we click on the chemical symbol for carbon here and then just drop that anywhere, it initially puts down a carbon, and there's a default 4 hydrogens attached to this. Now, this is just due to the fact that a lot of chemical drawing tools, whenever you choose a chemical symbol, will automatically attach hydrogens to your atom that you've placed down. So what we want to do is we want to, instead of drawing methane, CH4, we want to draw carbon, double bond to oxygen, and attach two hydrogens to that carbon as well. So what will happen is when we draw some bonds coming out of this carbon. Each time we put a bond down, it'll get rid of some of these hydrogens that came by default. So for instance, if we drag over here to another carbon, which we can replace with an oxygen in a minute. In fact, let's go ahead and do that now. This is our carbon-oxygen bond. Currently, it's a single bond, and again, you can see it's attached an atom, a hydrogen atom by default to this oxygen, and that will actually go away once we turn this into a double bond. And the way that we can do that is by simply highlighting the bond tool here, and instead of dragging, we can just take the bond that we previously placed down and click on that again, and you can see that's transformed into a double bond. If we needed to do this with a triple bond, we could simply click again and it would give us a triple bond. And if you click again after that, it should cycle back to a single bond. Alright, so that's our carbon-oxygen double bond. Let's go ahead and draw in the actual two carbon-hydrogen bonds. Again, with the bond tool, usually it inserts carbons by default, so we want this central carbon here to be attached to hydrogens. You might notice that the carbon here at the center of the molecule is no longer explicitly labeled. This is actually kind of how things work in what are called line angle diagrams, which is a common way of drawing organic molecules, where carbons are assumed to be at the intersections of single, double, and triple bonds, and you don't actually explicitly write in the symbol. But using this tool, this is the correct structure for formaldehyde. We also don't need to include any lone pairs on the oxygen because part of line angle diagrams, and this is covered in your book, is that you also don't need to explicitly include lone pairs on atoms, or I'm sorry, on molecules that contain only hydrogen and second row elements. Okay, hopefully this tutorial has been helpful. If you have any questions about how to use this, I'd definitely be happy to talk to you on an individual basis, either via email exchange or we can get on Microsoft Teams and discuss it face-to-face if you think that would be more helpful. So I'll go ahead and wrap things up here. And again, please contact me if you have any further questions about how to use any of these tools.